Hi folks, we are about to begin chapter 11 on solutions and their properties. And to start out with today, we are going to just work on those definitions for solutions again. Just want to remind you that a solution is a homogeneous mixture of two or more substances in a single phase. It does not have to involve liquids. We could have other solutions like an air or gases can be solutions where air, it contains nitrogen, oxygen, carbon dioxide, etc. Another example of a solution is in the solid phase, which is solder, which is a solution of lead and tin. Please remember that a solution always has two parts: the solute, which is the component in lesser concentration, the thing that gets dissolved, or the dissolvee. The solute ends in E, it's the dissolvee. You can also think about it as the thing that you are dissolving, since it has the solute, the U in the solute. And then finally, the solvent, which is the component in greater concentration, the thing that does the dissolving, or the dissolver. Now, in order to calculate concentration, we have several equations, and this is actually not a conclusive list, but these are the ones that you'll need on the AP exam. So to start with, we're going to look at the equation for molarity. As we've seen for molarity in the past, it's equal to moles of solute divided by liters of the entire solution. Of course, this is the symbol M, capital M to be more specific. And another way that this is sometimes shown, especially for a particular substance, you'll see, like if we're talking about the concentration of salt in solution, you'll also see that substance in brackets set equal to that concentration, and that's going to be really important for us in the next few chapters. Another way to calculate concentration is the mass percent. This is the same percent that you've been doing your whole life. The mass percent is going to be equal to the mass of the solute, the part, over the whole mass of the solution times 100. And then a final way that you can calculate concentration is actually using the mole fraction. And if you remember, we did learn about the mole fraction back in chapter 5, especially helpful when we were dealing with partial pressures of a gas mixture or solution. And so here, just to refresh our memory, the mole fraction symbol is chi, that weird X, and it's a Greek letter. And so the mole fraction will be calculated as the moles of solute over the moles of solution. You can think of that denominator as being a total moles of solution. Remember, mole fractions are unitless as well, because moles top and bottom end up canceling out. Now we're going to look at problem number 1, where we are looking at a solution in calculating these different molarity, mass percent, mole fraction calculations. All right, so problem number 1 says a solution is prepared by mixing 1.00 grams of ethanol, C2H5OH, with 100 grams of water to give a final volume of 101 milliliters. Calculate the following for this solution. So the first thing we have here in part A is the molarity. we know the equation for molarity is moles of solute. And this time we have to keep in mind, well, what's our solute? In this case, we have liquid ethanol because it's in the smaller concentration. So C2H5OH over liters of solution. And I'm just going to tell you today the moles of ethanol. I know that you can make that calculation of 1 gram over the molar mass. And so molarity here will be equal to 0.0217 moles of ethanol over the liters of the solution, and it was 101 milliliters divided by 1,000, and we end up with 0.101 liters. And so our final answer here would be 0.215 molarity would be our concentration of ethanol. Another one that we will need to know, again, is the mass percent in Part B. Here we're looking at the percent as the mass, in this case, of ethanol over the total mass of this solution. It tells us in the solution information that we have 100 grams of ethanol and 100 grams of water. And so this one's pretty cut and dry. To get our percent, and of course we do have to multiply by 100. But to get our percent, we'll just go ahead and put our 1 gram of ethanol over the 101 grams of C2H5OH, the total, 1 plus 100 there, times 100. And we end up with a mass percent of 0.990% ethanol. And then finally we have one more to deal with, which is the mole fraction. And so for the mole fraction, we will need to put the moles of solute over the moles of the solution. And again, the moles of solute here, so this is chi of C2H5OH. Our moles of solute are 0.0217 moles of ethanol over the total moles. And so we'll have to take this, 0.0217 moles, plus then the moles of water. Well, how do you calculate the moles of water? We have 100 grams, and then we need to divide it by 18.02 grams per mole. And that comes out to be 5.55 moles of water. So when you solve for that mole fraction, the mole fraction again, which has no units, will end up being 0.00390. A very small amount of moles in comparison to that of the total solution. All right, that's all for today. We'll go ahead and pick up here at problem number 2 tomorrow during class. See you then.